Okay, so I'd like to look at this kind of intro to graphing rational function sheet, just to kind of get an idea of how we can piece the things together, and then we'll actually take some formulas and go through all of our calculations and that stuff. In number one, you know what? Take a moment right now. I would like you to draw the asymptotes in, use the ruler to draw those, and fill in your number lines. Don't yet put the sketch of the graph on there. I want to do the graph with you, but I think you can handle the other pieces on your own. No max, no min, no point of inflection, so no points we can get on this thing. Hey, what are you looking for? Very, very, very quickly. Yep. Have you figured out your top number line by now? Hopefully one of those shapes and one of these shapes. Concave down decreasing, concave up decreasing. Bless you. So when we go to graph these, the asymptotes, well, the horizontal or slant asymptotes would tell us kind of where we're going to start when we're far left or far right. And the vertical asymptotes are lines we're not allowed to cross. We can get close to them, and it'll kind of shape the graph as we go along. I'm going to start close to my horizontal asymptote. If I want to take on this sort of shape, should I actually start above the horizontal asymptote or below the horizontal asymptote? A little bit below, actually, because when we're far left and far right, we really shouldn't be crossing them. By the way, is it ever okay to cross a horizontal or slant asymptote?
Yes.
Yes, in the middle of the graph. When you're far left, far right, you're going to be close to it and not crossing things. Never okay, though, to cross vertical asymptote. I'm going to start over here, and I want to be concave down decreasing, but I've got that vertical asymptote over there. So basically, be concave down decreasing until you get to that vertical asymptote. It's going to look something like that. Then I need to be concave up decreasing. Well, to take on that shape, shall I start up high or down low on the other side of the asymptote? Up high, so I can be concave up decreasing. So I'm going to start over here. And I'm going to curve around and again kind of level out at that asymptote. That's that. Not too bad yet. Do everything but the graph for number 2. Ignore the limit part for right now. Just graph those 2 asymptotes. I'll tell you exactly what the limits mean in a moment. Something like that. Now, the point of these limits is I'm telling you the limit as x approaches infinity of f of x is 4, which means when we are far to what side? The left or the right if we're approaching infinity? The right. When we are far to the right, we're going to be by the horizontal asymptote of y equals 4. And limit as x approaches negative infinity gives you negative 4. That means when we are far to the left, we'll be close to that horizontal asymptote. That's the left one. This is the right one. Okay, so I'm going to start by y equals negative 4. Concave up increasing until we get to that point. You can definitely finish this. And I'm going to be concave down, increasing, and leveling out over there. Still not too bad? Number 3. Do everything but the graph. Oh, does this look wrong to you? The max is -4, -2. The min is 2,6. Graph things. We'll talk. Maybe I got it wrong. Maybe I didn't. I probably didn't. I've used this sheet before. Do you think you can go and do the graph? See if you can do the graph. If you want to wait, that's fine too. If you do the graph, do it in pencil. Are you ever allowed to cross slant asymptotes, by the way? Yeah. They're the exact same idea as horizontal asymptotes. We got to be close to them on the ends. We can certainly cross them in the middle, though. Horizontal and slant function in a similar way. Vertical are different. So when I'm far to the left, I'm going to be close to that slant asymptote. Got to be concave down, increasing until I get to that relative max. So I've got something like this. Then concave down, decreasing after that. So then like that one. Because I need to be concave up, decreasing, I'm going to start up here and be concave up, decreasing until I get to the point of inflection. Then I'm going to curve around like that. Then I'm going to be concave up, decreasing, and then concave up, increasing. I think I showed you one kind of like this before, but is it now totally reasonable by the max is lower than the min? Do you see how I graphed this? Are there questions on what I just did? Anyone? Anything? Okay. It's already 10:10. Hopefully, yes, James. Yep. So, are you okay with the two shapes I have over here? Concave up, decreasing, then concave down, decreasing. If I want to be concave up, decreasing, if I want to take on that shape, I'm going to have to start up high. So I need to start over here rather than somewhere down here. I need to take on that concave up, decreasing shape till I get to my point of inflection. Then I need to switch over and become a concave down, decreasing, which is what I'm doing over there. Okay. hopefully we are going to have time to get through 2 full examples. We'll do the best we can. Fair warning that this is going to be a little unpleasant. Messier than it was last time. That's really the deal. So let's see what we can do now, just taking a formula and sketching things. So let's see. Do it like this, then it's not on a slant for you guys. It is November 9th. And we're still looking at section 3.6. Curve sketching, day 2. And our first of 2 examples, we are going to sketch the function f of x equals x over 4 minus x squared. The first thing I'd like you to deal with is figure out the asymptotes. This is what that reading was all about last night. I'd like you to figure out if there are any vertical asymptotes, and then give equations of those. And then if there are horizontal or slant asymptotes, decide which one, and then find an equation of that. What are the vertical asymptotes? Those aren't equations of asymptotes. There we go. X equals 2 and x equals negative 2. These always come from setting your denominator equal to 0. Factor it if you want. You could probably just look at that, though, and know it's going to be 2 and negative 2. But we could factor if we want to see it like that. Is there a horizontal asymptote or a slant asymptote? Horizontal. What's like the thing you're looking for, Olivia, to figure that out? Good. What would tell you slant? Good. And that's not the case over here. So I am going to go to try to find horizontal asymptotes. How do we do that again? James? Limit as x goes to infinity. We should probably also do negative infinity, but I think you know here it's going to be the same thing. Of x over negative x squared. Well, I'll cancel out an x. I'll make this the limit as x approaches infinity of negative 1 over x. What's that limit? 0. What's the horizontal asymptote? Y equals 0. When I go to do my graph later, I'm going to start by plotting these things. I'm going to have to make sure I kind of bend the curve to kind of fit. That's wonderful. To kind of fit those asymptotes. Okay. Now, we need to deal with the first derivative. You can handle this. Do it based on the original, not like factored version, and use the quotient rule. So I've got my first line written out, but then you do need to simplify that thing because we'll have to find the critical values, and the form it's in right now is not so useful. This is not terrible simplifying. This is not what I meant by it's going to get messy. That's coming. Getting a first derivative of x squared plus 4 over 4 minus x squared squared, I hope. Critical values, what do we get from the top? From the top? From the top? Why are you saying no? Yeah. Set it equal to 0, you're going to get plus or minus square root of negative 4, nothing real. So they're all going to come from the denominator. Yeah, there are two critical values at 2 and negative 2. Make your number line. And you know what? I feel like I could even cheat a little bit when I go to do my plugging in, because no matter what you plug in, what's true about the denominator? Always positive. So we can kind of skip that part and just focus on the numerator. Oh, that's kind of interesting. Okay. So positive, positive, positive. Shall I say that I'm increasing from negative infinity to infinity? No, because the derivative is not positive at negative 2 and at positive 2. So we will say increasing from negative infinity to negative 2, and then between negative 2 and 2, and then from 2 to infinity. No maxes, no mins. Hopefully you realize that. Okay. I would like to do the next piece with you, because here's where it gets messy. The second derivatives are going to be a little ugly. The good news, though, is they're always going to be handled in the exact same way to kind of deal with the ugly stuff that happens here. Second derivative. I'm going to take this form of the first derivative. I'm going to do my second derivative. I could move things up. I think I'm just going to leave it, though, and use quotient rule. When I go and use quotient rule on that thing, I'm going to get low 4 minus x squared squared. D high. Easy. What's d high? How about just 2x for d high? Minus high. Minus x squared plus 4. Here's where we have to be extra super careful. Julia, question so far? Because I'm doing low, d high. This 2x comes from doing the derivative of x squared plus 4. Minus high, x squared plus 4, d low. Be careful. What do we need? Oh, good. Okay, so what's the first part of chain rule going to look like? 2 times 4 minus x squared to what power? First. Do you need anything else? Yes. What do we get? Here's where we're going to get our negative 2x. Draw the line and square below. This is going to give us over 4 minus x squared squared squared. Why don't I just say 4 minus x squared to the 4th? I am going to just kind of clean up each of the terms. No foiling or distributing at this point. I'm going to rewrite this as f double prime of x equals 2x times 4 minus x squared squared. Not minus. I'm going to make it a plus because of my double negatives over there. 2 times 2x is 4x times x squared plus 4 times 4 minus x squared all over 4 minus x squared to the 4th. I still don't really want to start doing foiling things yet. What nice thing do you see that we can do, Adish?
I think we can cancel out 1 4 minus x squared.
Yeah, if it was me, I would first factor out that GCF. And then cancel. You could also just kind of go and cancel right away. You will always have something like this that you can do to make this thing nicer, because honestly, if you do start foiling things up top, you're going to end up with a cubic thing you're not going to be able to deal with. So do look for a GCF thing. There will always be one that you can take out and then cancel. I'm going to take out a 4 minus x squared. I'm actually going to do more than that. What else? And a 2x. Let me take out a 2x and a 4 minus x squared. I'm left with 4 minus x squared from the first piece. 2 times x squared plus 4 from the second piece. And this is all over 4 minus x squared to the 4th. The point of doing that was so we could cancel a 4 minus x squared. So I'm going to get 2x up top, 4 minus x squared to the 3rd on the bottom. And then I am going to go distribute and deal with things. 4 minus x squared plus 2x squared plus 8. And we should be able to get a second derivative that looks like that mess. Well, not really mess anymore. Possible points of inflection where? Yep, you realize why nothing's going to come from the x squared plus 12? You're going to make your number line. Make sure you're labeling it f double prime. -2, 0, 2. Can I use that trick from the last time and just kind of ignore the denominator because it's always positive?
No.
Not in this case because we're cubing things. Could be positive, could be negative. Test your regions, figure out your signs. What's the first sign? Anyone have the first sign before -2?
Positive.
I think it's positive. So first of all, I am going to ignore part of this. I'm going to ignore the x squared plus 12 because that will always be positive. So plug in -3. 2 times -3 is negative. -3 squared is 9. 4 minus 9 is a negative. Cube that, it's still a negative. So we get a negative over a negative. It's a positive. -2 to 0. -1. Plug that in. What do you get? I am not sold there. I'm thinking negative. Top is negative, bottom will be positive, so negative there. Plug in 1. You mean you wanted that instead? Good. Plug in 1. Positive. Plug in 3. As usual, you can't assume it's always going to alternate like this, but it did in this case. Okay. It's time to put all this stuff together, so I'm going to draw some axes. Oh, wait a minute. No, I'm not done. You know what? I'm not going to bother listing concavity because we're running out of time a little bit. You can handle those parts. Points of inflection. Do I have 3 points of inflection? No, but I see 3 places where. Second.
But there's asymptotes there.
Aha. If you forgot about that and tried to plug -2 into the original, you'd get undefined for the y value, which is your reminder that, yeah, there is an asymptote there. So -2 won't be a point of inflection, although it was important to have on our number line because that's where we change sign. 0, though, will be a point of inflection. 0, comma, I think it's just 0 when you plug into the original. So I'm going to draw my axes. I'm going to draw a vertical asymptote at x equals 2, a vertical asymptote at x equals -2, a horizontal asymptote at y equals 0, and I'm going to put a point at 0, 0. Below here, I'm going to do my number lines. So we've already done the number lines. I'm just going to sort of redo them so they're all kind of stacked and in one place because I think it makes it easier to graph that way.
There was a horizontal asymptote.
Sure. Yeah, a little tough to see, but it's on the x-axis.
So wouldn't then 0, 0 also not work?
You plug 0 into the original, you will get 0. Remember the issue with horizontal asymptotes is we can't cross them at the ends. We could cross them in the middle. Like that third example from the packet we looked at with the slant asymptotes, we did cross it, just not at the ends. So it will be okay there. If you think you can finish this off, try it. If you'd rather wait and watch me, then do that. Question, David?
I just thought that the y-axis was the third thing.
No. I haven't graphed the curve yet. Yeah, that's not the straightest y-axis I could have drawn. I'm going to start by the horizontal asymptote. I'm going to be increasing concave up, so I'm going to curve around and look like this. I'm then going to jump to the other side of the vertical asymptote. I want to be increasing concave down, so I've got to start low, so I can be increasing concave down up until there. Then I'm going to be increasing concave up, so I'm going to switch to this sort of shape. I want to end with one of those things, so I'm going to start down low so I can be increasing concave down and curve around to the asymptote. Questions here? We are going to do as much of a second example as we can get to. So we're going to take a look at the function f of x equals x squared minus 6x plus 12 over x minus 4. Find the asymptotes. Vertical, I think, should be very easy. What is it? X equals 4. Have you decided if it's a horizontal or a slant asymptote? Slant, yeah, because the degree of the numerator, one more than the degree of the denominator. I'm thinking y equals x minus 2. Should be that slant asymptote. Justin.
Do we have to calculate the domain?
Yeah, I guess you can probably just stop once you figure out your constant term. I think I'm okay with that. Okay, we are running out of time. I'm assuming you can handle your first derivative of this thing. Let me just tell you what the first derivative will be. You'll use quotient rule. You'll do some work. You're going to get x. So, hold on. First of all, let me label this as the first derivative. We're going to get x squared minus 8x plus 12 over x minus 4 in parentheses squared. After you use quotient rule and all that. You'll do that in the homework. Go deal with that now. I think you can factor the top, make your number line, do all that sort of work. Oh, I do see something nice with the plugging in. What am I talking about? That I can, like, ignore. Denominator, always going to be positive. So we really, we can just focus on the top. What was that? Got to get the right formula. Please Please turn the phone off. Take it out, turn it off. You know if it was yours. Thank you. Take it out, turn it off. Make sure that doesn't happen again. Before 2, what are we, positive or negative? Between 2 and 4. Between 4 and 6. Negative. After 6. I'm not going to bother writing things out here, but I think you can figure out there's a max at 2 comma something, min at 6 comma something. Figure out the other coordinates. Plug into the original function. Yep. 4 is a critical value because it made our denominator equal 0. Critical values, remember, come from both parts. Nope, don't do that. Okay, so I'm going to plug 2 into the original. 4 minus 12 plus 12 over 2 minus 4. 4 over negative 2, maybe negative 2 for a y coordinate. To negative 2, 6 comma 6. I do want to go through the second derivative calculations. Maybe we'll start together and then you'll go do the simplifying. And if you do this properly, the simplifying will be very, very nice at the end. Our second derivative. Again, I'm just going to go use quotient rule, and I'm going to use it on this version over here. Low, easy. What's d high? What's d high? 2x minus 8. Minus high. X squared minus 8x plus 12. What's d low? Draw the line. Square below. See if you can handle the factor out the GCF stuff and cleaning this up. If you do this properly, it will look very nice when you're done. While you do this, I'm going to start passing out the cumulative review due next Friday. Then we'll take a break for Thanksgiving. And also the chapter review, because after today, there's only one more day left. Our test is next Thursday. You may want to start doing a little bit of looking at stuff over the weekend. Go do some simplifying while I pass some stuff out. Homework a little later, but I do want to get yeah. What was that? Ah, so I gave them the extra one. That's yep. There are no answers in the back of the review packet because I made some big changes to the one from last year and haven't done the problems yet. So I'll do them over the weekend. I'll give you the answers on Monday. I'll get my scanned in stuff probably up on Monday. I will say I think it looks longer than it really is because of just spacing with some things. This is also cut down considerably from last year, just throwing that one out there. You might not believe it, but it's true. So I really hope you factor out an x minus 4, because then we can cancel with 1 in the denominator and get just x minus 4 cubed there. Then I do see some FOILing and some distributing that I will need to go do. So x squared minus 8x. Now I lost it. Minus 8x plus 32 minus 2x squared plus 16x minus 24. What was that? More than just that. You're just going to get 8. Your second derivative is 8 over x minus 4 cubed. Do your number line. Negative, positive. Point of inflection at 4. Why not? Asymptote there. Again, if you forgot that and tried to plug in, you'd realize when it's undefined there. See if you can piece this together. I'm going to pass out the homework. There are 5 problems, 5 graphs you're going to do in the homework. However, for 2 of them, I gave you the original function. You have to go through all this stuff. For 3, 4, and 5, I gave you the original function, but I also told you the first derivative and the second derivative. So really, I want to see, can you just do the analysis of those? Because I do realize this is messy work. So again, see if you can finish this one off. Yep. Yep. I'm going to leave the container of rulers on the little table over by the door. Please make sure on your way out you return my rulers. Okay, vertical asymptote x equals 4. Slant asymptote, if you want to hang around and finish the graph, you're welcome to do that. I'm going to keep going. I've got a slant asymptote like that. I've got a max at 2, negative 2. I've got a min at 6, 6. By the way, in addition to the homework that's on the board, please start bringing in food. Next week, I will post the sign-up sheet online. Please do bring in what you signed up to do. Let's see. So, and Paulina, did you get that form to Miss Smith? Yes.
Sorry for the scheduling. I'm gonna one more time. Can we just say Monday instead of after school today? Or Tuesday?
Okay, give me one
Like, just
second.
next
First
week.
of all,